Hey everyone, welcome back. I hope you're all doing great. In today's video, we're going to dive into the lesson on how to use the precedence diagramming method, PDM, for scheduling construction projects. But first, let's take a look at the learning objectives for this lesson. This lesson has 3 learning objectives. 1, use the forward pass and backward pass to calculate ES, early start, EF, early finish, LS, late start, and LF, late finish. 2, calculate float time, including total float, TF, free float, FF, start float, SF, and finish float, F and EF. And 3, determine critical activities and identify the critical path. Let's start with the basic definitions of activity times. There are 4 types of activity times. Early start, ES. It is the earliest time an activity can begin. Early finish, EF. This is the earliest time an activity can be completed. Late start, LS, refers to the latest time an activity can start without delaying the project. Finally, late finish, LF, is the latest time an activity can be completed without delaying the project. Now, here's how you should organize the activity times in the activity node. The activity box is divided into several sections. The activity name is placed in the center of the box. Early start, ES, goes in the top left corner, and early finish, EF, goes in the top right corner. Late start, LS, is placed in the lower left corner, and late finish, LF, in the lower right corner. The activity duration is placed at the bottom between late start and late finish. The remaining space is for the total float, which you'll learn more about in the next lesson. Please remember this rule: time in PDM is always referred to as the end of day. To better understand these concepts, let's walk through an example. Here, we have a bar chart schedule for a project with 4 activities. The immediate predecessors, IPAs, for each activity are listed in the second column. Now, let's analyze this schedule and determine the activity times. As mentioned earlier, in the precedence diagramming method, times are determined at the end of the day. Starting with activity A, the earliest it can begin is at the start of day 1, meaning its earliest start, ES, is at the end of day 0. Since it can be completed by the end of day 1, its earliest finish, EF, is 1. Moving on to activity B, its earliest start is at the start of day 2, which corresponds to the end of day 1. So its ES is 1, and it finishes by the end of day 4, meaning its EF is 4. Following the same process, we determine the early times for activities C and D, as shown here. Looking at the final result, we can see that the early finish of the last activity, D, is 6, which matches the total project duration. Now that we've determined the earliest start and finish times for each activity, what about their latest start and finish times? Let's move on and find out. To calculate late times, you need to determine how much you can delay activities without affecting the project's overall duration. Let's start with activity A. Imagine you want to delay it by 1 day. How would that impact the project? Would it extend the timeline? Well, to answer that, you need to understand the dependency relationships between activities. For example, looking at the IPA column, we see that activity A is the predecessor for both B and C. So, if A is delayed by 1 day, both B and C's finish times will also be pushed by 1 day. Since activity D follows C, its finish, and ultimately the project finish, will also be delayed. This means that activity A can't be delayed, and its late times will be the same as its early times. Now, let's look at activity B. It doesn't have any successors. What's the maximum delay you can apply to B? To find it, we can move B's finish to the project's finish, which in this case is day 6. This gives us the late start and late finish for activity B, respectively at the end of day 3 and day 6. What about activity C? Since it is followed by D, which is the last activity of the project, any delay in C will affect D, and therefore the project will be extended. As a result, C's late times will be the same as its early times. For activity D, because it's the last activity of the project, it can't be delayed without impacting the project's finish. Therefore, its late times will be the same as its early times, late start at day 4 and late finish at day 6. As you can see, while calculating activity times using a bar chart schedule is possible, it can be very time-consuming and challenging, especially for large projects with hundreds of activities and complex relationships. Later on, you'll learn the precedence diagramming method, which is a more efficient way to calculate activity times. As mentioned earlier, to support mathematical calculations in PDM, we use the end of day as a reference for all activity times. These times should be understood as specific time points. For example, an early start, ES, of 0 means the activity starts at the end of day 0, while an early finish, EF of 1, means the activity finishes as early as at the end of day 1. The figure below illustrates the relationship between the times in a precedence diagram and the calendar of a bar chart schedule. In this case, PDM time starts at 0, which corresponds to the beginning of day 1 on the bar chart schedule. It's important to keep this in mind when converting times from a precedence diagram to a bar chart schedule, or vice versa. Alright, that wraps up this video, where we explored the different time components of an activity, how to present them in a precedence diagram network, and how to map these times onto both a Gantt chart and a precedence diagram. We'll see you in the next video. Goodbye.